Ever since you were a kid, you've been taught math. Sorry to break it to you, but you have seen almost nothing.
That's why, when I say I love math and I think it's wonderful, many people really don't get it, think that I'm crazy or something. But actually, they don't even know what math truly is about, what you can do with it, or what I see in it that they do not. As weird as it may seem, I want to dedicate my life to it. And with this video, I'll try to make at least some of you appreciate its beauty as well. Coming up with a perfect definition for this field of science is no easy task. It is so complex, yet fundamentally simple, that this is the object of many debates. Math studies patterns, quantity, structure, change, and much, much more.
It takes real-life problems and turns them into abstract models to be studied. It is the base for all sciences, and it itself relies on a series of logical propositions that are assumed to be the undeniable truth, called axioms.
Unlike other sciences, math works in absolutes.
In here, you need to have something you know is true in order to prove something else is also correct, and that only works when you have a starting point you know is right.
That's where axioms come into play. They're the first fact in everything, and they are needed to get anywhere else. From axioms, you take something you know is true and you use it to prove your way up the ladder. Because of the nature of maths, they're the only exception. Each field inside of math has its own set of axioms, derived from what was observed needed to be true in order for everything to work as expected. To make it easier to grasp, let's visualize it using an example, the set of all natural numbers, which is actually derived axiomatically.
We begin by saying that 1 is a natural number. Afterwards, we establish the equality's properties. It is reflexive, so a number x is equal to itself. It is symmetric, so if x equals y, then y equals x. It is transitive, so if x equals y and y equals z, then x equals z. And it is closed, so if x equals y and x is a natural number, then y is also a natural number.
Wait a second. You may notice how simple and obvious all these axioms seem to be. Why do we even need them? Well, without stating them as facts, they could not always be proven, and therefore, math as we know it could not exist. With that out of the way, let's get to defining the successor of a natural number. We say that the successor is a closed function. This means that for any natural number n, the successor of n is also going to be a natural number. And we also say that for any natural number, s of n is not going to be equal to 1, as 1 is the first natural number and no number precedes it.
Finally, we say that if we start with 1 as our only number, and we apply the successor function infinitely many times, we get the whole natural set. Therefore, every natural number can be derived from these two axiomatic definitions. For example, 4 is the successor of the successor of the successor of 1. Then 5 can be obtained by performing the successor of 4, and so on and on.
Through pure logic and reason, theorems, properties, lemmas, and other logical propositions can be demonstrated and then used on and on and on to prove others. This becomes a huge interconnected web of increasingly complicated propositions that work in syntony in order to continue to push the edges of math further. This also means that we can take almost any problem and generalize it to be studied through math. Because, as you can see, we can reach lots of conclusions by analyzing abstractions of everyday and not so everyday problems and questions. A mathematician doesn't just spend his day calculating the solutions to quadratic equations, as some may imagine, but they rather wreck their brains looking for answers to problems not yet cracked by anyone.
In number theory, for example, a pair of twin primes are two prime numbers, only divisible by 1 and by themselves, that are only separated by an even number, such as 3 and 5 or 11 and 13. As numbers get bigger and bigger, primes start appearing further and further spread from each other. The twin primes conjecture states that there is no last pair of primes that satisfies the property. In other words, there are infinitely many pairs of twin primes.
This has not yet been solved, and its solution could help with so many other unsolved problems in the same or related fields of algebra. This quite basic and simple question has an uncountable number of sub-problems, results, and added complexity than what it looks like. It may even help advance theories of true randomness in physics, or in calculating predictions for some kind of subatomic particle model. Mathematicians look at some specific characteristic of a field, draw conclusions from it, and publish them. They study new stuff every day and they document it, investigating in the most pure way there is, playing with logic and letting their minds free to address problems from every point of view you could imagine. And they don't start from the bottom. They use each other's previous papers or books, citing lots of works from everywhere around the world, and going forward with the subject at hand. Unrelated people from different sciences, universities, or continents will help each other, without even exchanging a word or knowing each other's names. So many people doing little things in their preferred fields with the help of others can lead to gigantic steps, and thanks to everybody's efforts, to their life's works. This is academia. After everything we've seen and talked about, there's nothing else for me to say but that math is great. And if you like this line of work, you should really consider it. Being a mathematician is so much more than just being good at doing multiplications and divisions in your head. It is about creativity, imagination, and loving every second of having your mind blown. Toying with the fundamental concepts of reality, fighting with intuition and logic, and challenging yourself day to day, not leaving any space unexplored, or time to rest for your brain. It's about learning, relearning, and destroying your preconceptions. I want to dedicate my life to it. And now you know why.